Hey guys, welcome back to the channel. In today's video, I'm going to be showing you guys how to run an optimization for selling calls. This should ideally be used for option selling and collecting premiums. In this script, we're just going to try and optimize for what delta we should use, the number of days left to expiration on when we should open the position and also close it, and also what strike we should use. Now, since the script is only optimizing for premium collecting, we're going to insert some columns where you can run this optimization as if you had 100 shares for every option that you sell. Now, you are going to need an options database. I'm going to be using end of day options data to run this optimization, and the look back period is just going to be year to date. So here are some of the packages we're going to require. I'm going to be sourcing some functions that will pull options data from my database, and the stock we're going to be using is Mara. I've commented out some code here, but all that it's doing is just getting the options data from my database. So if we take a look at ops, just to give you an example of what that data contains, we have the implied volatility, the theta, the option name in full, the delta, the expiration date, the flag, the strike price, where the stock closed that day, the trading day of when this data was collected, the number of days left to expiration, the mid price, and then the stock symbol. Using this table, we're going to go ahead and build a function where we pass in a vector of trading days, and for each of the trading days it's going to seek the best combination that yields the best Sharpe ratio for selling these calls. So back in our script here, we're going to extract a unique vector of trading days in my table. We're going to split that table at the 70% mark, so 70% of the data is going to be used for testing, the other 30% is going to be used for validation. And for the actual function, which is called sell calls, we're going to pass in our vector of trading days, the delta that we seek to sell the call, the number of days left to expiration of when we should sell the call and also close it, and the percentage difference between the underlying and the strike at the time of the open. So within this function, I placed another function that'll calculate the P&L of a single trading day given the parameters that we pass in. And then this is the function that we're going to go ahead and pass in into this lapply by passing in our vector of trading days. Once we have the functions in place, we can go ahead and focus on the optimization parameters. The first two lines in this block are just extracting the dates for our testing data set and our validation data set, which will be used later on in the script. So for each of the parameters that you list, we need to set the minimum and maximum. So for example, for deltas, I want to focus on a minimum delta of 5 all the way up to 70, and you can play around with these values here. Just make sure you have the same number of parameters that will be used in the optimization. We also need to build a formatting function, so depending on what you're optimizing for, we need to go ahead and round each of these values to certain decimal places. So for the first and last, I'm just rounding to 2 decimal places. For the number of days to expiration, I want to keep these as integers, so I'm just rounding everything to 0. For the optimization, it'll go ahead and pass a vector of values for each of the parameters and test and seek to minimize. The first thing we're doing in this function is making sure that the second parameter is higher than the third, and that's the number of days to expiration of when we open our call and when we close it. So we need to make sure that the optimization checks that before running our function. Once we extract all the returns for the trading days we pass in and it didn't generate an error, we're going to calculate the Sharpe ratio. If it triggers an error or if the second parameter is less than the third, it's just going to assign the Sharpe ratio to -100. And since this optimization seeks to minimize, we're going to return the negative Sharpe ratio, which in turn means that we're actually maximizing this. Once you have set your optimization parameters, we can move on to the next block. And this is where we actually do the optimization, and we're going to use de-optim. We're going to pass in our function that returns the Sharpe ratio. We're going to pass in our lower and upper values. The control list, I'm just setting the iteration max to 25, which is the number of iterations it will do before stopping the optimization. And then finally our fnmap or formatting value function, which is included in the optimization. So for each of the iterations, it'll step through and try and seek to find the maximum Sharpe ratio. And as we see, it returns 4 values, each one for each of the parameters in our function. So we have our deltas, we have our days to expiration, and the percentage difference between the strike and the underlying price at the open. My recommendation is that you set this itermax to at least 100, depending on your computing power. And we see that for each of the steps, it returns the Sharpe ratio. So at step 25, our Sharpe ratio was 8.4 given these 4 parameters. So it's saying that for this particular stock, we should sell a call 69 days approximately before expiration. We should close it when the days to expiration is approximately 6. The delta of the call when we open our position should be less than or equal to 7%, and the percentage difference between the strike price and the underlying price at the open should be at least 13% higher. Once the optimization is done running, we can go ahead and extract these values, and we're going to assign that into vals, and we're going to pass in each of those into our function, still using our test dates. And if we plot the cumulative sum of premiums we collected, we see that it's not the most exciting thing, but again, this is doing it for each of the trading days in our vector. What we want to do now is extract the cumulative sum of premiums we collected for each day of the week, since it's not the most opportune thing to be selling premium each of the trading days. And the way we do that is we're going to go ahead and assign the day of the week for each of the trading days, and we generate this table. Given the day of the week, we see the sum of the premiums and the average return. So it looks like for this particular stock, Wednesdays were probably the best at selling premium. And if we plot the cumulative sum of returns for that day of the week, we see that the cumulative sum of the premiums we collected is a little bit more optimal than just selling premium each day. What we want to do now is see if the optimization holds at a sample. So here in this next block, we're going to use our validation dates and pass in the best optimization parameters. And we see that the at a sample cumulative sum of premiums we collected is not all that great. But if we just use the day of the week, we see that the strategy still holds. Since the optimization only considers the premium we collected for selling naked calls, what you can do to incorporate the premium or the gain that we collected between the purchase price and for selling at the strike price would be to optimize not only the option return but the stock return for that particular position. So you would change line 125, and this way you optimize two things at once. Well, with that, guys, this concludes the video. I hope this code was useful. Please let me know what you guys think. I'll leave a link down in the description area to my Patreon where you can find the script. Please consider subscribing to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.